In this problem, we are given the first few terms of a sequence, and we are asked to write the formula for this sequence and then use it to find the 1,234th term. Now right away you want to check to see, is it arithmetic? So you can see that we're adding 4, but then we're adding 6. So right away that wipes out that this can't be arithmetic. Then you want to check to see, is it geometric? We would multiply by 3 to go from 2 to 6, but then multiply by 2 to go from 6 to 12. So I know it's not geometric either. Now, there's a lot of different ways that you could find the equation for this, but a lot of the ones that we've seen in class have happened to have a quadratic form to them. And so you could see that the difference between 2 and 6 is 4, 6 and 12 is 6, 12 and 20 is 8, 20 and 30 is 10. Well, if you look at the second difference, we end up getting 2, 2, and 2. And so the fact that we have constant second differences, that tells me that this will look like a quadratic. Well, that gives us a clue that since it's a quadratic, we're probably squaring something. And so I'm going to write out the first couple terms to try and see how our term n relates to the term that it corresponds to. So if I know that it's quadratic, I'm going to start by taking 1 squared. 1 squared is 1. To get to 2, I'd have to add 1 more. This is all t sub n. So 2 squared is 4. To get to 6, I'd have to add 2. 3 squared is 9. To get to 12, I'd have to add 3. 4 squared is 16. To get to 20, I'd have to add 4. 5 squared is 25. To get to 30, I'd have to add 5. And so the pattern here is that we're squaring n and then adding n. And so our formula does indeed look like a quadratic. Well, now that we have the formula, we can use this to find any term that we want by simply just plugging in the term number n. So I'm going to go ahead and square 1,234 and then add 1,234. And so we end up getting that term to be, it looks like 1,523,990. Now on the next example, we're going to look at the same sequence, so that means it has the same formula. Again, looks like a quadratic. And we're going to use it to work backwards because we're told what one term is. We need to find which term. So we're looking for n. So now we're going to set it equal to our formula. So again, this looks like a quadratic, so we're going to solve it like a quadratic. And so I'm first going to subtract over this term to get everything to one side. And you could try and factor it, but since this is such a large number, I'm going to go ahead and jump right to the quadratic formula. So our a is 1, our b is 1, and our c is this negative 11 million number. So we'll have negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Now, keep in mind that the quadratic formula always gives us 2 answers. However, in this problem, we're looking for a number of a term in the sequence. And so the only answer that's going to make sense is a positive integer. And so from here, I'm going to type the entire numerator in the calculator, and I'm going to add the 2 together to see if that will give me my reasonable answer of 1 squared minus 4 times 1 times this large number, which is negative. Make sure you don't forget that negative. It will change your answer quite a bit. So there's my numerator. I'm going to divide that by 2, and I end up getting 3,367. Again, I'm not even going to go through finding the other one because since we would be subtracting, it would give us a negative answer. So what this means is that we would have to find the 3,367th term until we would expect to see this number in the sequence.